Now we're going to look at some division models. We've done addition, subtraction, multiplication. Now it's time for division, and we're going to stick with whole numbers. So one of the first ways that you can show how to model division is using a number line. And this is something that I expect you to know how to do. I expect you to be able to draw it or see one drawn and know what's being modeled. But sometimes students have trouble with this, and I'll explain kind of as we go. So what you're going to do is we're going to use a repeated subtraction model. Remember, multiplication was repeated addition. Well, division is repeated subtraction. So you're going to repeatedly subtract the same amount, that's called the divisor, from the whole amount, that's called the dividend, until you get all the way down to 0. So for a quick example, Sally baked 18 cookies and she wants to separate them into containers that hold 6 cookies each. How many containers will she need? So the only numbers that we have are 18 and 6. So the only numbers that should be reflected on your model are 18 and 6. Now you probably already know what the answer is. But think about if you were showing this to kids, right? So we would start with 18. We'd start down here at 18. And what she would do is she would take 6 cookies and she would put them into one container. So you go down 6 until you get to 12. Then she'd have 12 cookies left, and then she would put 6 more in a container. Now she's down to 6 cookies. She's going to subtract 6 more, and you'll notice that you end up here at 0. So you just, how many 6s can you subtract from 18? That's what you do, right? So subtract 6, subtract 6. So you're starting at 18, and we're going down 6, 6, 6 until we get to 0. This is where you're going to stop. And then what you do is you go back and you look at how many times did you actually subtract 6. And you'll see that it's 3, I'm going to call them jumps. We took 1, 2, 3. It took 3 subtractions to get us all the way down to 0. So that means that 18 divided by 6 is equal to 3. So 18 is where you start, 6 is what you subtract, 3 is the answer. So a lot of times what students try to do is they'll take the 18 and they'll go, well, I just cut it into 3 equal pieces. But think about that from a student perspective. A student would be looking at that going, where'd you get 3? Like, how did you know that 3 was in the problem when all they see is an 18 and a 6? So sometimes, because it's like muscle memory for us as adults at this point, like 18 divided by 6 should be muscle memory at this point. So sometimes because we know the answer, we allow the answer to creep into the model, but that's not the correct way to model it. So you start at 18, subtract 6, and then at the very end you count how many times did I subtract 6. Now this is assuming that we get a remainder of 0, which is kind of the idea here as we're starting with whole numbers. All right, so that's how you model repeated subtraction. Oh, and again, I should probably put on here, this is where you start and the 0 is where you stop. Okay. Then there's a partitioning model, and this is probably the way that everybody first learned how to divide, is you take the whole and you just divide it into groups. So if we say Sally baked 12 cookies and she wants to give them to 3 friends. So here's her 3 friends. Maybe these are plates for her 3 friends. One way that you can do it is partitioning. And this is like literally how you would do it if you were sitting at home in your kitchen counting out the cookies. You would go, for each of the friends, you would go 1 for you, 1 for you, 1 for you. 2 for you, 2 for you, 2, and you just kind of count as you go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we divvied up, essentially, all of the cookies. And you can see that each friend is going to get 4 cookies. This one gets 4 cookies, 4 cookies, and 4 cookies. So 12 divided among 3 friends. Because see, the 12 and the 3 is what was provided in the problem. So 12 divided by 3 equals the number of cookies on each plate. So the answer is actually how many are sitting in each group. So 4 cookies each is what each friend would get. That's called partitionings, where you go 1, 1, 1, 1, 1, 1, 1, 1, 1, over and over and over and over again. Which is really inefficient if the numbers are large. And if you get a remainder, it's kind of a problem too. The last way is what's called the missing factor model. You saw one before that was called the missing addend model. That's where we turn subtraction problems into addition problems because they're easier. Well, guess what we're going to do? We're going to turn the division problem into a multiplication problem because multiplication is inherently easier than division. So it says think of the division as a multiplication problem and then solve it by finding the missing factor. Remember, two things that are multiplied together are called factors. John has 27 baseball cards that he wants to place evenly into 3 different albums. How many baseball cards will go in each album? So the question we're really trying to figure out is this: what is 27 divided by 3? But what we're going to do is we're going to think of it backwards. We're going to go back this way, and we're going to say, what number times 3 would give me 27? And then this way you can just think about it as a multiplication problem. And if your students know their multiplication facts, they should know that 3 times 9 is 27. So the question mark would equal 9. And so that means that 27 divided by 3 is 9. But it's just kind of like the mental thought process that you go through. So this one is kind of hard to draw. Like there's nothing to really draw like there was with partitioning and repeated subtraction. This is just kind of a more mental way to do the problem, is to spin it around and try to figure out what the missing factor is.